Keeper 6.4 virtual problems. Make sure you have your virtual problems printed out and ready to work along with me. All right, so one important thing I wanted to note from the lesson, so from the video notes, is your formula for your what we call a definite integral. And so we say this is a definite integral when we have bounds. And so in this case, our bounds are A and B. And so when you have bounds on your integral, what you're going to do is you're going to integrate it, and then you're going to put in your bounds. And so you put in your top bound to whatever you get when you integrate it, and you subtract it from your bottom bound. So top minus bottom. All right, so the first question we have says find the value of the definite integral. Show your algebraic work. So here's our integral from -1 to 1. Notice I'm reading from bottom to top, -1 to 1 of t squared minus t dt. All right, so here's our integral, and the first step I want to do is actually integrate it. And so remember, when we integrate, our main rule is our power rule, in which we add 1 to our exponent and then divide by the new exponent. So when I integrate the first one, I'm going to get t cubed over 3, and then the second one would be t squared over 2. And we're going to do that from -1 to 1. And notice my notation. I put a straight up and down line to denote that I'm about to put in the bounds from -1 to 1. Now again, from our formula, you want to always start by putting in your top bound. So this 1 is what I'm putting in first. And once I get that 1 in there, then I'm going to subtract it from the -1. And so I get the top bound of 1 cubed over 3 minus 1 squared over 2. And then I'm going to subtract my bottom bound. So minus, notice I put a big set of parentheses, and I have -3 cubed over 3 minus -1 squared over 2. Once I have my setup, from here is simply algebra. So I'm just going to work this out. So like 1 cubed over 3 is 1/3, minus 1 squared over 2, that's 1/2, minus parentheses, -1 cubed over 3 is -1/3, and then minus -1 squared over 2 is 1/2. And so when I write that all out, I get 1/3 minus 1/2 plus 1/3 plus 1/2, again, making sure that you distribute your negative in. So the negative gets distributed here, and it gets distributed there. And so once I get that, I want to add it all up. If you notice, your 1/2s are canceling, and you're left with 2 over 3. All right, so our next example, we have the integral from 1 to 2 of 3 over x squared minus 1 dx. All right, so the first thing I would do is I'd probably rewrite my integral to be 3x to the -2 minus 1 dx. And then I'm going to integrate it, again, using my power rule by adding 1 to my exponent and dividing by my new exponent. I have 3x to the -1 over -1 minus x from 1 to 2. Now, before I plug in my bounds, I want to clean this up a little bit just to make my problem a little bit easier. So when I clean it up, I'm going to have -3 over x minus x from 1 to 2. Now remember, when you plug in your bounds, you got to plug in the top bound and then plug in the bottom bound. So I'm going to plug in the 2 first to get -3 over 2 minus 2. And then I'm going to subtract that from plugging in this bottom bound of 1. So minus -3 over 1 minus 1. All right, now again, after I plug in my bounds, it's just a matter of doing some algebra. So I have -3 over 2 minus 2. Plus 3 plus 1 if I distribute my negative in, and then adding all that up, I get 1/2. All right, so for this example, we're going from 1 to 4 of u minus 2 over the square root of u du. Again, working this out, trying to integrate it, I'm probably going to clean it up first by dividing and conquering or splitting it up. And so I have u over square root of u minus 2 over square root of u. Now again, I would work this out a little bit more before I actually integrate it by simplifying my exponents. So I'm going to do u over root u, which would be u to the 1/2, minus 2u to the -1/2 du. Once I rewrite it and I get it how I want to get it, then I'm going to go ahead and integrate it by adding 1 to my exponent and dividing by my new exponent. So I would get 2u to the 3/2 over 3 minus 4u to the 1/2. And again, I'm integrating that from 1 to 4. All right, so starting with that 4, again, starting with your top bound, you're going to plug that in. and then you're going to subtract off your bottom bound. So you have 2 times 4 to the 3 halves over 3 minus 4 times 4 to the 1 half minus 2 times 1 to the 3 halves over 3 minus 4 times 1 to the 1 half. Now simplifying this out, we get 16 over 3 minus 8 minus 2/3 plus 4. Again, make sure that you distribute your negative. All right, now after you do all that, again, you want to just add this all up to get your final answer. And so I get 14/3 minus 4, which is just 2/3. Next, we have the integral from -2 to -1 of x minus 1 over x squared. Once again, I'm going to rewrite this integral just to make it a little bit easier. So I have x minus x to the -2. Then I'm going to integrate it. So I get x squared over 2 minus x to the -1 over -1 from -2 to -1. Just rewrite it before I actually plug in my bound. So I have x squared over 2 plus 1 over x from -2 to -1. And then I plug in my bounds. Remember to plug in your top bound minus your bottom bound. So I have -1 squared over 2 plus 1 over -1 minus all of -2 squared over 2 plus 1 over -2. Simplifying that out, I get 1/2 minus 1 minus 2 plus 1/2, which simply leaves me -2. All right, next example is a trig example. So we have the integral from 0 to pi of 1 plus sine x dx. Again, I'm just going to integrate this to start off. I don't have to rewrite it. It's already in a nice form. So I have x minus cosine of x from 0 to pi. And then I'm plugging my top minus my bottom. So I have pi minus cosine pi minus 0 minus cosine 0. Now using my unit circle to simplify that, I know that cosine of pi is -1 and cosine of 0 is 1. So I get pi minus cosine pi plus cosine pi, or pi minus -1 plus 1, which is pi plus 2. All right, so our next example, we have the integral from 1 to 3 of 3x squared plus 5x minus 4 dx. Again, integrating this thing, I get x cubed plus 5 over 2x squared minus 4x. And again, I'm running that from 1 to 3. Plugging in my top bound and subtracting off my bottom bound, I get 3 cubed plus 5 halves, 3 squared minus 4 times 3 minus, and then my bottom bound would be 1 cubed plus 5 halves, 1 squared minus 4 times 1. Doing a little bit of algebra to simplify this out, I get 27 plus 45 over 2 minus 12 minus 1 minus 5 halves plus 4. And then adding all that up, I get 38. All right, so this one's a little bit different because I'm giving you guys the graph and I'm asking you to find an integral based off the graph. So the integral that we're trying to find for the first one is the integral from -4 to 2. Now remember, integrals are simply areas with direction. So like if your area is above the axis is positive, but if your area is below the axis is negative. And so when I look at from -4 to 2, I notice that this is underneath, or this portion of the graph is underneath the x-axis. And so again, when I'm looking from -4 to -2, I'm breaking it up into pieces. So I'm breaking it up here to have a trapezoid, and then this piece is a triangle, and then I have a triangle here that's above the x-axis. So I have 2 pieces below, and then I have a piece above. All right, so for the first piece of the trapezoid, we have to remember our trapezoid formula, which is 1/2 height times base 1 plus base 2. The height of this trapezoid is actually laying sideways, and so my height is actually going to be 3. And then my base here is 3, and my base over here is 2. So when I set up my formula, I have negative, because it's below the x-axis, 1/2 base of 3 times 3 plus 2, which are my other bases, or sorry, height of 3, and then base 1 plus base 2, which is 3 plus 2. Then I'm going to add on this triangle piece from -1 to 0. And so I know the formula for a triangle is 1/2 base times height, but again, it's going to be negative because it's below the x-axis. So I have -1/2, 2 is my height, and then my base is 1. And then for the last one, I have another triangle. So from 0 to 2, I have a triangle. So again, I'm using that 1/2 base times height formula. but again, it's going to be added because it's above the x-axis. So I'm going to say plus 1/2, a base of 2, and a height of 2. Now simplifying all this out, I get negative 15 over 2 minus 1 plus 2. And then cleaning that up, I get negative 13 over 2. All right, so our next example, we have the integral from 0 to 3, f of x dx. So again, I'm starting at 0, and I have a triangle from 0 to 2. And we've already calculated that triangle out, but we'll do it again. And then I want to go from 2 to 3, which is below the axis, so I know that's going to be negative, and that's also a triangle. So for the first triangle, I have 1/2, 2 times 2, or base times height. All right, and then minus the triangle that's underneath would be 1/2. I have a base of 1 and a height of 2. And again, cleaning that up, I get 2 minus 1, which is 1. All right, next I have the integral from negative 1 to 1 f of x dx. So I'm starting at negative 1, which is a triangle below the axis. And then I'm going to 1, which is the exact same triangle, but above the axis. So the first triangle is negative 1/2, 2 times 1. And the second triangle is positive 1/2, 2 times 1. Well, if I add those together, I'm going to get 0. All right, so this next problem, they're asking us for the integral of the derivative. Now, if you really understand what's going on, if you integrate the derivative, you would simply just get the function value back out. So like the integral of f prime is simply f of x. And so in this problem, what they're actually asking us to calculate is f of 0 minus f of negative 4. Well, f of 0, looking at the graph, the point at 0 is 0, and the point at negative 4 is negative 3. So I have 0 minus negative 3, which is 3. Again, the same example, we have the integral from negative 1 to 1 of f prime, which again, the integral of the derivative is simply the function. And so we're going to have f of 1 minus f of negative 1. F of 1 is 2, and f of negative 1 is negative 2. So I have 2 minus negative 2, which is 4. All right, last example, we have the integral from 1 to 3 of f prime of x. So again, f prime with the integral is simply the function itself. And so they're really asking for f of 3 minus f of 1. F of 3, looking at my graph, f of 3 is down here at negative 2. And f of 1 is 2. So I have negative 2 minus 2, which is negative 4. If you guys have any questions, please reach out to either me or Miss Bonanni, and we'll try to help you guys out. Have a great Thursday.